Good morning, dear student. Today in this class, let us start with a new chapter called as Electrostatic Potential and Capacitance. So this chapter carries totally 9 hours teaching and 8 marks weightage of this chapter. Here 1 marks question 1, 2 marks question 1 and 5 marks question 1 or 3 marks question 1 or 5 marks question 1. Totally it carries 8 marks weightage of this chapter. In this chapter, we are going to study about the concept called as electrostatic potential, potential due to electric dipole, potential due to system of charge and equipotential surface, potential energy of a system of charges, potential energy in an external field, electrostatic of conductor, dielectric and polarizations, capacitor and capacitance and parallel plate capacitor and few more concepts like effect of dielectric on capacitance, combination of capacitor and the energy stored in the capacitor. The last one is voltage of generator. These are the content are studied in this chapter, electrostatic potential and capacitance. So let us continue one by one. The first concept is electric potential. Electric potential. So what do you mean by electric potential? Electric potential in an electric field can be defined as it is a point in an electric field is defined as work is done by unit charge from a distance infinity to the given point in an electric field is called as electric potential. Electric potential is at a point in an electric field. Electric field is the work done bringing a unit positive charge from a infinite distance to a given points against the electric field. Suppose, so let us understand this concept. Consider an electric field, uniform electric field like this. So I just consider one line, one electric field here. So I place a point, I choose a point, this is P point, and place a charge on this point, place positive charge Q, that is 1 plus 1 coulomb of charge. Here, work is to be done when it is an electric field. When the charge is placed in an electric field, it experiences some force. So that force tends to move a charge towards the point. Then the charge gets displaced somewhere. So this displacement and force, the product of displacement and the force is called as work done. Here, observe here, electric potential is at a point in an electric field. The work is done bringing a unit positive charge. So this unit positive charge is moved towards the point, then only we can say that work is to be done. So here work can be defined as the product of force into displacement or S or ds. This is the actual definition of work done. Same thing happen here also, happen here. So the charge will be get displaced from here to towards the given points in an electric field against the electric field. Against means it opposite to the electric field. It is called as electric potential. Then what do you mean by potential difference? The next concept is potential difference. So potential difference can be defined as the difference between the 2 points in an electric field can be defined as work is to be done by bringing a unit positive charge is moving from one point to another point in an electric field is called as potential difference. Suppose the definition is like this. Potential difference is the difference between the 2 points. Difference between the 2 points in an electric field is defined as electric field is the work done is bringing by unit positive charge moving from one point to another point. One point to another point is called as potential difference. So consider an electric field like this. This is the direction of electric field. So I consider 2 points on this electric field A and B. Sorry, this is B, this is A. A and B are the 2 points in an electric field. I place a unit positive charge, 1 coulomb of a positive unit charge placed at a point A. Here the unit positive charge moved from A to B. Then only we can say that the potential difference. So it is defined as it is a 2-point difference in the 2 point in an electric field by work is to be done by moving a unit positive charge from A to B. This is called as potential difference. Potential difference can be written as VB minus VA. Here VA refers to the potential difference, potential at a point A, and VB refers to the potential at point B. So the mathematical form of this electric potential can be written as V equals to the electric potential or potential difference can be represented by a capital letter V, can be defined as work is to be done by unit positive charge. This is the mathematical form of electric potential. Then the potential difference is the difference between 2 points A and B, that is VB minus VA. Here VA and VB are the potential with respect to the point A and B. So electric potential and the potential difference both are the scalar quantity. The SI unit of both this electric potential and the potential difference are the SI unit of electric potential and potential difference is volt. It can be represented by a capital letter V. So this is the SI unit of these two. That is electric potential and potential difference. Both are scalar quantity, and the SI unit of both is volt. Volt V. It can be represented by V. It can be represented by a letter V, and also SI unit of these two can be represented by a letter V. This is regarding about a concept of electric potential and the potential difference of a point in an electric field. Next, we move on to the next topic, that is electric potential. Electric potential due to a point charge. So, consider a electric field. So, I point this place. This is represented by a letter O. This is a point, and another point P, and two more points. This is B. This is A, and this is the electric field at infinity. Electric field infinity, and the distance from O to P called as R, and the distance from O to A is called as X, and the distance from A to B is called as dx. And I place a unit positive charge plus 1 coulomb of charge at a point A. So, in this diagram, in the figure, here O represents O is a point Q. So, here Q is a charge. Placed at O in free space. And P is a point in an electric field from a point O at a distance R, and A and B are the 2 points on the electric field AB and separated by a distance dx, and here x is the distance from O to plus 1 charge. So this is the attributes of this figure. First one is Q is a charge placed at O in a free space. The next one is P is a point and in an electric field, and two more point charges, that is A and B, separated by a small distance dx, and x is the distance from O to A in an electric field. E is an electric field due to a point charges. This is regarding about the diagram. So, when we know that when the charge is placed in an electric field, it experiences some force. In the previous chapter, we learned about the Coulomb's law. The Coulomb's law says that it is a force of attraction between the two bodies, or force of attraction and repulsion between two bodies, two charges, can be defined as it is the product of magnitude of the charges and inversely proportional to the square of the distance between them. Same here also, the two positive charges Q and the plus 1 coulomb of charge from Coulomb's law. Here, the force of attraction taking place between Q and plus 1 coulomb of charge. Therefore, F equals to 1 over 4 pi epsilon naught q1 q2. Q here, q1 means q and q2 means 1 coulomb of charge divided by r square. R square means x square. This is the force of attraction taking place here. Then here the work is to be done. A unit positive charge work done is taking place from a unit positive charge moving from A to B can be defined as work done by plus 1 coulomb of charge moving from A to B is given by dW equals to minus F into dx. So, work done can be defined as we already know that the definition of work done. What is that? The work done means force into displacement. So, force here, the force into displacement. The charge get displaced from A to B. The distance is dx. The force is F. And the total work done by a 1 coulomb of charge moving from x equals to r infinity to x equals to r can be calculated by a integration method, that is the work done can be defined as integral of infinity to r dw. Work done is the total work done is the integral of infinity to r dw. So we put here the value of dw, then we get so substitute the value of dw to this equation number 1, we get w equals to integration of infinity to r. The value of dw is minus f dx. So substitute the value of f by the Coulomb's law, infinity to r minus 1 over 4 pi epsilon naught q divided by x square into dx. So these are the constant. Take it outside the integral. Minus q divided by 4 pi epsilon naught integral of infinity to r 1 divided by x square dx. Then minus q divided by 1 4 pi epsilon naught integral of 1 by x square. What is the value of 1 by x square? Integral of 1 by x square, that is minus 1 divided by x. The limits varies from infinity to r. So here also minus, the minus into minus plus, then q divided by remaining thing, q divided by 4 pi epsilon naught 1 divided by x infinity to r. So apply this limit to this variable, we get q divided by 4 pi epsilon naught 1 divided by r minus 1 divided by infinity. Here the 1 by infinity, the value of 1 by infinity is 0. Since 1 divided by infinity equals to 0, so put the value of this, q divided by 4 pi epsilon naught r 1 divided by r remaining thing. So therefore the final equation we get equals to Q divided by 1 over 4 pi epsilon naught Q divided by R. This is the total potential in an electric field due to a point charge. But here the left side is W. But here I will write V because for a charge 1 coulomb V equals to W. That's why I will write V here. This is the final equation regarding this electric potential due to a point charge in an electric field. So here the V is called as electric potential. But further we can say that this is the potential difference between the points R to infinity, where the electric potential can be placed in a positive charge. When V is placed positive charge in air, the equation becomes V equals to 1 over 4 pi epsilon naught Q divided by R. When the V is placed in minus Q in a air, the equation becomes V equals to 1 over 4 pi epsilon naught minus Q divided by R. This is regarding about the potential difference and the electric potential in an electric field. So let's continue. The next topic will continue in the next class.